Today on Aqua Kids,
we're back at the Virginia Institute of Marine Sciences Seagrass Greenhouse, where we're going to learn about SAVs.
Submerged,
Aquatic
Vegetation.
You guys are 3 steps ahead of me. Let's go learn about them.
Aqua Kids, doing what we have to do. Saving our earth, land, air, and sea. All we gotta do is keep it green and blue. For me and you. Aqua Kids.
Hi, I'm Hannah Jones. Today on Aqua Kids, we're at the Virginia Institute of Marine Sciences on the York River, which flows into the Chesapeake Bay.
The Chesapeake Bay is the largest estuary in the United States.
with the northern part in Maryland.
and the southern part of Virginia.
And the bay is very important to this region's ecology and economy. So is the health of the plants and animals that live here. Today we're going to talk about the connection between scallops and SAVs. Let's get started.
Hey, there's Ken over there.
Hey, Ken.
What's going on?
Hey guys, how you doing? Let me show you.
Looks like a bunch of mud to me.
Actually, there are important things in here. There are eelgrass seeds hidden in this mud.
Really?
And we use these for seagrass restoration in areas that used to have seagrass and no longer do.
So what happened to the grass beds? Where did they go?
Well, they died out, and over the last 20 to 40 years in this region, we've had a big development in the coastal zone, and a lot of the runoff and pollution has caused the seagrasses to decline.
So coastal development, what does that include?
Coastal development, that's everything that we know as the habitat we live in, cities, towns, and the farms. So here are some of the seeds with the mud removed.
Look at that.
Looks like
sesame
seeds.
Yes, they're very small. The dark black ones are the ones that are the most ripe, and they're the ones we want.
Well, how do you separate them?
Separating them is a long process. In the spring, when the seeds are produced, we harvest the shoots that have the seeds on them just before they're released. We bring them back here and allow the shoots to decay in these big tanks that you see behind you. Then we gradually remove them from the tanks and get more and more concentrated until finally we end up with just the seeds and a little bit of the organic matter that's connected.
Then what?
Well, then we hold these until, in this area in the Chesapeake Bay, until October. That's when they normally begin to germinate. They germinate in the fall around here because eelgrass, this species, likes cold water.
So that's the same process that would happen out in nature.
Correct, exactly the same. But we find it's better to harvest the seeds, bring them in and hold them here, and then take them back to places where they are most useful, areas where there's no existing eelgrass to repopulate that area.
Why is that?
Well, that's because those areas have died off. In some cases, they have not recovered because there's no source of seeds nearby today. And so we have to start a founder or beginning population. Once that gets going, then the beds will be able to maintain themselves as long as the water quality is good.
So after you have this small concentration of seeds, you just go throw them in the water?
We've tried different ways of planting them. Of course, it's very hard to plant these seeds underwater with a diver. They do sink to the bottom, but they're adapted to go into the sediments very quickly by themselves because that's how they're naturally sown. So we go out and take these and lightly sprinkle them over areas that we want to seed. And we found from our experiments that within a few hours to a day or more, they actually get buried.
So where does this type of SAV grow?
This type of SAV grows in shallow areas where the salt or salinity, the salt content, is very high.
Are there SAVs that grow in freshwater?
There are many species of SAVs that grow in freshwater. We only have one species of true seagrass that grows in salt water, and that's this one around here in the Chesapeake Bay. But we have almost 40 species that grow in freshwater.
Can we see some?
I have a few over here if you'd like to see them.
Let's go.
Now it's time for Aqua Quiz with your host, Drew Cruz.
Ladies and gentlemen, I'm your host, Drew Cruz, and it's now time for you, the viewer, to test your knowledge with Aqua Quiz. Let's get started. Underwater grasses, also known as Submerged Aquatic Vegetation, or SAV, are one of the most important components of the Chesapeake Bay ecosystem. SAV beds were once so abundant that their mats of floating vegetation fouled propellers, stopping boats from navigating many of the bay's shallower stretches. But now, these plants occupy only a fraction of their historic areas. Do you know what has caused the demise of these critical plants? Is it A, runoff and suspended solids, B, excess nitrogen and phosphorus, C, low levels of dissolved oxygen, D, algae, or E, all of the above? We'll have the answer after the break. So have you come up with the answer? Do you know what has caused a decline in bay grasses? The answer is E, all of the above. Recent decline in water quality caused by excess nutrients and sediment has caused a significant loss in bay grass. Excess nutrients cause algae populations to grow rapidly or bloom. An overabundance of algae contributes to two problems in the bay: reduction in sunlight and reduction in dissolved oxygen. And erosion and runoff create floating particles in the water column that also block critical sunlight needed for the plants to thrive. We'll see you next week with another Aqua Quiz.
Welcome back to Aqua Kids.
Let me show you what I have over here.
So these are all freshwater SAVs.
Correct. These are plants that grow in fresh water or in areas in our estuaries where the salt and salinity is very low.
Now, will these ever come above the surface of the water?
No, they only will grow underwater or just up to the surface. They have to stay underwater all the time, or they will dry out and die.
So what species do we have here?
Well, we have 4 species. The first one in that beaker is called sago pondweed, and it grows, as you might expect, in ponds and in lakes, but also in the upper part of our estuaries where the water is very, very calm.
So what's this one?
This one is called wild celery or freshwater eelgrass. It's very similar to the saltwater eelgrass as far as how it looks, but it grows in a much different environment.
So what are the benefits of having SAVs?
Some of the benefits are these are important habitat for fish, turtles, and other animals that live in the water. They stabilize and hold the sediments, much like the grass on your lawn would. They can take nutrients out of the water, so the water becomes clearer and cleaner. They can take carbon out of the atmosphere and store it in the sediments. And of course, that is an issue today as we produce a lot of carbon from our own human activities.
So these can replace our above ground forests.
They can. They won't replace them, but they can add to the value that the forests have for the world. In fact, it has been determined that submerged aquatic vegetation and seagrasses worldwide may take as much carbon out of the atmosphere as our forests do.
Wow.
Now, this species is called dwarf spike rush, and on there you're holding the flower. Freshwater SAV, unlike true seagrasses, like eelgrass, can have to release their pollen at the water surface or into the atmosphere in order for them to produce seeds. One of the reasons is, as you know, plants developed in the oceans as algae, moved into the land, and then became flowering plants over many, many hundreds of millions of years, and then reinvaded the oceans as flowering SAV.
Interesting.
The first place that they reinvaded was the freshwater environments. And so they still kept their atmospheric or air methods of reproduction.
Wow.
Much later, seagrasses developed, and they were able to flower and release pollen underwater. So we've talked about several methods of reproduction. One is they produce flowers and seeds. One is they spread by rhizomes or stolon. But in many freshwater species, they can spread by breaking off little pieces, and those little pieces grow. In some cases, that can cause problems. And we have several introduced species, one of which is here, that can become a nuisance in many water bodies where its abundance gets too great.
What is an introduced species?
An introduced species is one that isn't native, hasn't been here for a long time. It's only come in the last maybe 50 years or more. And because it hasn't grown here for a long time, it doesn't have good controls. And that's usually the problem with introduced species.
So what did we learn today?
Well, SAVs benefit the ecosystem in 3 ways. First, they provide a home for organisms to live. Second, they help to hold the sediment together. And third, they help to filter pollutants in the water.
Like pores, it buries carbon.
SAVs spread and reproduce in many ways. Some are actually invasive, and we need to be aware about spreading them.
Don't go away. More with Aqua Kids when we come back. Hi, Hannah here. For more information on today's show, go to aquakids.tv. Welcome back to Aqua Kids. We are headed out into the Chesapeake Bay with Dr. Mark Lukenbach of the Virginia Institute of Marine Science. Dr. Lukenbach is heading up a project to restore the bay scallop population in the lower Chesapeake Bay. As the bay grasses began to disappear in the early 1920s, so did bay scallops. We're here with Dr. Lukenbach from the Virginia Institute of Marine Sciences.
Today, we'll be talking about the Bay Scallop Restoration Project here in Virginia's coastal Bay area.
Dr. Lukenbach, tell me a little bit about your project with the bay scallops.
Okay, well, I'd be happy to. So, first of all, the area that you see around here, the coastal bays, this is high tide now, so you wouldn't be able to see any seagrasses, submerged aquatic vegetation, which used to live in this area. It was abundant in the late 19th century, early 20th century. A species called eelgrass is a real important habitat for the bay scallop. The bay scallop lives attached to the eelgrass as a small juvenile and then falls onto the sediment surface after that to live the rest of its approximate 2-year lifespan. So what happened is, following them being very abundant here, we had a large-scale disease that was occurring with the eelgrass in the 1920s, the late 20s, and the grasses began to decline, and with it the habitat for the bay scallop. Almost certainly it would have held on, except that there were 2 large storms in 1933 that literally rolled the barrier islands over. The barrier islands are the islands you can see out there in the distance that form the outer edge of this lagoon system. It rolled those over and buried the seagrasses, the eelgrasses, and with it we lost not only the eelgrasses but the habitat for the bay scallop. And for nearly 75 years, neither one of those existed here. Then in the late 1990s, we decided to give an attempt, a colleague of mine, Dr. Robert Orth, and I decided to make an attempt at restoring eelgrass to this area, which we do by collecting seeds from other places and spreading the seeds. And we were amazed, frankly. We went from having no eelgrass to having, as far as I know, if not the largest bed of eelgrass in the world, certainly the largest eelgrass restoration project.
Congratulations.
Thank you. And so what we did on 3 successive years, beginning in 2009, was to collect a small number of bay scallops from North Carolina. And then back in a research hatchery at our laboratory, we spawned those beginning in 2009 and then in 2010 and 2011 to make our own Virginia, what we call brood stock. So we had several hundreds to a few thousand adults. There you go. Now those are some of the juveniles. They were spawned in May of this year. So we bring adults from the brood stock that we now have, we bring them into our hatchery, our research hatchery. We're able to spawn them.
Spawn in a lab? How do you spawn these in a lab?
A good question. I would say candlelight and soft music, but that wouldn't work with scallops.
No.
Actually, what you do is we bring in animals from the field that are almost ripe. That is, they've almost got fully ripe egg and sperm. We feed them a nice diet of algae in the laboratory, and then on the days that we want them to spawn, you can often get them to do that by raising or lowering the water temperature.
So how's the restoration going so far?
Really very encouraging. We initiated this process, as I said, in 2009 by literally having to build our own brood stocks. Over the next few years, we managed to get tens to eventually 100,000 animals out in the field at the time. This size or a little bit smaller, and we would we'll keep those in cages for a while. The reason we keep them in cages is both to protect them from predators, but also to make sure that when they spawn, they're next to one another, so there's high fertilization. So what's really more encouraging than just that we're seeing them in the grass bed where we planted them is as this grass has started to spread through much of these coastal bays, we're getting reports that the scallops are showing up in many of the other grass beds. We found some of them as well. We don't have a population estimate. So the answer to your question is we're very encouraged. We don't think we get to stop our efforts yet because the population doesn't appear to be dense enough out there to have successful reproduction on its own. But we're really encouraged by it. We're going to give it another 5 years of trying, and if we're successful, what's going to be really extraordinary is that we will have restored this species to a place that has been extinct for about 85 years.
Oh my God. Wow.
Oh, hi. I'm so glad you're here. You know, it always excites me to meet young people who love to protect the earth as much as I do. Young people who are pioneering powerful ways to conserve and protect our planet for all of us. I call them eco-defenders. Let's find out what they're up to.
My name is Amira Odem. I'm 22 years old and I'm the president of the Eco-Environmental Society here at the University of Puerto Rico. For me, growing up at the island, he was a huge inspiration. Having rivers and seeing the ocean. Water has been very important to me in my life. Our campaign, No Más Botellas, our ultimate goal is to ban bottled water to eliminate the bottled water vending machines from campus. Bottled water, it's an unnecessary commodity. In Puerto Rico, we have excellent tap water quality. People are not using it. We think that the water that we need to drink is bottled water. The plastic problem is a really big issue in Puerto Rico. We don't have much space to put our waste, and barely anything is recycled in Puerto Rico. This eventually ends in our rivers and the oceans, and plastic never goes away. This campaign actually started as a research project. I never expected it to grow as it grew like this, and the more I learned about this problem, the more I felt I needed to do something. The drinking fountains in this building were in very bad condition, so we worked with the administration to have new drinking fountains installed. We also do a lot of information tables and orientation events, and we also sell reusable bottles at a good price to motivate students to stop buying bottled water. Activity I do mostly day to day is reaching out to people through social networks. It's the best way to expand our message. There are around 15,000 students in our campus, and to have 15,000 people know about this issue that is not much talked about around the island, it will be a very huge step in our campaign. We not only want to ban bottled water here, we don't want this movement to stay just in this campus. We recently started to talk to other environmental student organizations in other universities and offer trainings about our story, our campaign, and motivate other people to expand to the whole island movement.
Amira is very determined. Sometimes, people pick on her like, oh, you're always working and stuff, but she just enjoys it so much that for her it isn't work at all.
Environmental education and environmental protection is my passion. I love doing this. As a little girl, I noticed that someone really needs to do something and not just wait for things to happen. That someone needs to do something, and I want to be that person for our generation and future generations.
Wasn't that amazing? Okay, now it's your turn. If you or someone you know is doing something remarkable to help our planet, let us know about it, and you could be our next eco-defender. I gotta go. Want to keep up with our adventures? Follow us on Twitter and Facebook.
Aqua Kids will be right back.
Hey, Drew here. Be sure to join us next week as we travel to the Marine Academy of Science and Technology to learn about how they're partnering with the U.S. Fish and Wildlife Service to protect piping plovers, plus a rare up-close and personal moment with young ospreys.
I'm Jalen, and this is Earth Edition. Some things can be both a help and a hindrance. These things are often misunderstood. That is true of aquatic vegetation. Many people would prefer not to have it in their favorite place for swimming or boating, but aquatic plants and seeds are food for many birds and animals, including ducks, geese, otters, beavers, muskrats, and turtles. Humans use aquatic plants as a food source and for medicines too. These plants provide shelter for fish, frogs, and salamanders, and scallops. They also help protect shorelines from erosion caused by currents and waves. And aquatic plants help water quality with their ability to cycle nutrients and pollutants. So what's the problem with aquatic vegetation? There's just too much of it. Non-native or invasive aquatic plants upset the local ecosystem of the water by crowding out the useful native plants. I'm Jalen, and this has been Earth Edition.
Welcome back to Aqua Kids. So Drew, we learned today that the intercoastal development is depleting SAVs.
SAVs are what baby bay scallops need at the beginning of their lives.
So restoration of the SAVs is important to the bay scallops. And remember, it's up to you to keep it green and blue. Help protect our planet, and we'll see you next time on Aqua Kids. Bye!
Aqua Kids, doing what we have to do. Saving our earth, land, air, and sea. All we gotta do is keep it green and blue.